All right, strap in everyone, because today we are taking a deep dive into the science behind Interstellar. You guys sent us some really cool excerpts from Kip Thorne's book, The Science of Interstellar.
Yeah.
And let me tell you, it's really got me thinking about space in a whole new way.
Yeah, it's pretty amazing. Kip Thorne, he's a leading physicist, actually worked on the film to make sure the science was accurate. Like, he really gets into the mind-blowing realities of black holes, warped time and space, how big the universe really is. Things we always see in sci-fi but don't really wrap our heads around.
Exactly. And he explains it in a way that, well, even I can almost understand. Like, he starts with this universe in brief section. It's like a crash course on, well, everything from the Big Bang to black holes.
Yeah, he really lays it out there. And Thorne, he really emphasizes how huge the universe is, which makes you realize, right, how challenging interstellar travel would actually be. Like, even getting to the nearest stars would take some serious leaps in technology.
It's kind of humbling, isn't it? Like, whoa, we really don't know that much. But okay, let's talk about these black holes for a sec. Thorne makes it clear that they're not just, empty holes. They're actually regions where gravity warps both space and time.
Oh, yeah, it's mind-bending stuff. Think of it like a bowling ball on a trampoline. You know how it warps the fabric around it? That's kind of how massive objects affect space-time. At least that's what Einstein's theory of relativity tells us.
Whoa, okay, hold on. So gravity isn't actually a force,
Mm-hmm.
but it's a consequence of this warping. Okay, my brain needs a minute to process that.
Uh-huh. Yeah, it takes some getting used to. But it explains why time slows down near a black hole. Remember that scene in Interstellar,
Yeah.
where Cooper comes back to Earth and he's way younger than everyone else?
Oh, right, right. That's time dilation, isn't it? Like
It,
a real thing that Einstein predicted.
exactly. It really makes you wonder about time, doesn't it? Is it really constant or does it, change depending on where you are?
Okay, see, this is what I mean, mind-blowing stuff. And then Thorne mentions this whole other idea, something called the bulk. He says it's this higher dimensional space that our universe might exist within.
Yeah, the bulk. It's a bit of a head scratcher.
Right, like imagine our universe is a flat sheet of paper. The bulk would be like the entire space that sheet exists in.
Yeah, and maybe with other universes too, who knows?
Whoa, other universes. That's getting a little too out there even for me.
Haha, I know, right? But that's what I love about Thorne. He really encourages us to think about these possibilities, like even the really weird ones.
Okay, so let's focus in on Gargantua for a minute, that supermassive black hole in the film. Thorne says that, get this, everything about a black hole can be known from just two things: its mass and its spin.
Yeah, it's called the no-hair theorem.
It's like a cosmic fingerprint.
And it's pretty wild because it means that even though black holes have these crazy effects, their basic properties are actually really simple.
But Gargantua is anything but simple.
Hmm.
I mean, Thorne says it's 100 million times heavier than our sun. And it's got a circumference as big as, like, Earth's orbit.
Yeah, and it's spinning, like almost as fast as physically possible.
Seriously.
Yep. And all that spinning, it actually affects how Gargantua looks, the shape of its shadow and that ring of fire around it.
Oh, right.
It's because light actually gets trapped in orbit around the black hole. Crazy, huh?
Absolutely mind-blowing. You know what else blew my mind? The fact that they actually used real equations and scientific calculations to create the visuals of Gargantua in the film.
Oh, yeah, for sure. Thorne worked super closely with the visual effects team to make sure everything looked as accurate as possible.
Talk about dedication to detail. I
Yeah.
mean, they even use this technique called gravitational lensing, right?
Yeah, gravitational lensing.
Where light from distant stars gets bent by the black hole's gravity.
Exactly. It creates these distorted images and effects, like the Einstein ring.
It's amazing how, like, scientific rigor can actually enhance the artistic impact of a film.
It's true. It makes the whole thing even more awe-inspiring.
It really blurs the lines between science and art, wouldn't you say?
Definitely.
Okay, but let's talk about how the Endurance actually gets around this monster black hole. Enter gravitational slingshots.
Ah, yes, the slingshot maneuver. So basically, to navigate near Gargantua, you'd need some insane speed changes. And gravitational slingshots, they use a massive object's gravity to change a spacecraft's path and speed. Thorne explains how it could provide the boost they need.
Well, we actually use this technique with planets in our solar system, right?
That's right.
But scaling that up to a black hole, I mean, it's like using a cosmic slingshot to fling yourself across the galaxy.
Uh-huh. Yeah, pretty much. And in the film, Cooper and his team, They might even be using smaller black holes that are orbiting Gargantua for these slingshots.
Wait, smaller black holes.
It's possible, and it shows just how important these intermediate mass black holes could be for advanced space travel.
Wow, that's wild. So you've got these crazy gravitational forces happening around Gargantua, but back on Earth, humanity's facing a whole different kind of problem, right? This global blight that's wiping out crops.
Yeah, that part really got me thinking. Thorne's take on this blight scenario, it makes you consider just how fragile our planet's ecosystem really is. It makes you wonder, how prepared are we for a large-scale ecological disaster?
Right, right. Good point. It's pretty sobering when you think about it that way.
Yeah, it's a scary thought for sure. And then there's Professor Brand. Remember him? He's worried about oxygen depletion. Do you think that could actually happen?
Yeah, that had me wondering too. Is it really possible for the Earth to, like, run out of oxygen like that?
Well, Thorne gets into it. He talks about what might happen if there was a massive decay of organic matter.
Hmm.
And basically, he says it's probably not going to get as bad as it does in the movie, but it does highlight how delicate the balance is in our atmosphere and how important it is to understand how all these systems work.
Right, right. Absolutely. It's kind of like we take breathing for granted, don't we? But okay, so back to Interstellar. Earth's in trouble, so they got to look for a new home, which brings us to interstellar travel.
Yeah, and the distances between stars are just mind-bogglingly huge. Even if we could travel at like a good chunk of the speed of light, these trips would take centuries, maybe even millennia. It's almost impossible to imagine.
So how do you even begin to, like, bridge those distances?
Well, Thorne explores a few futuristic ideas, like thermonuclear fusion rockets, which use the power of nuclear fusion for propulsion. And then there are laser-powered light
Light
sails.
sails, those are those giant reflective sails, right?
Exactly, and they'd be propelled by these super powerful
I've
lasers.
heard of those. Sounds pretty sci-fi.
Oh, yeah. It's definitely still way beyond what we can do now. But it's based on real physics. Thorne even throws in his own idea, which is using a binary black hole system for, like, a cosmic slingshot.
A black hole slingshot. Okay, you got to
Yeah.
explain that one.
Haha. All right. So picture this. You have two black holes orbiting each other, right? And if you can maneuver a spacecraft just right, you could use their gravity to accelerate it to crazy speeds.
Like using black holes as a cosmic billiard table.
Kinda.
Yeah, that's intense. But in the film, they use a wormhole, right? It's like a shortcut through space and time.
Yeah, the wormhole. Thorne actually dedicates a whole chapter to, like, the theoretical physics of wormholes. He describes them as, like, tunnels through space-time, connecting two points in the universe that would normally be super far apart.
Okay, I'm trying to picture this. It's like if you fold a piece of paper in half
Heh.
and poke a hole through it, that hole would be a shortcut between 2 points that are far apart when the paper is unfolded, right?
Yeah, that's a great way to visualize it. But the question is, could wormholes really exist?
So that's what I was thinking. It seems, I don't know, a little far-fetched, even for a sci-fi movie.
Well, Thorne says they're highly hypothetical, but they do fit with Einstein's theory of general relativity, how space-time can be warped and all that.
So it's not impossible, according to what we know about physics. But we haven't actually found any, right?
Exactly. And even if we did find one, to make it big enough for a spacecraft and then keep it stable, that would take an unbelievable amount of energy and, like, control over gravity that we just don't have.
Yeah. That sounds a little beyond our current capabilities.
Yeah.
But in the film, this wormhole just appears near Saturn, right? And it was put there by some advanced civilization, like a cosmic gift or something.
Yeah, it's like they're giving us a helping hand.
But it makes you wonder, what if there really are civilizations out there that can do stuff like that?
Oh, absolutely. It's a mind-blowing thought, isn't it?
It really is. Okay, so back to the visuals in the film. Thorne says they even accounted for the gravitational lensing that the wormhole would have on the stars around it.
Oh, yeah. They really thought of everything.
So they go through the wormhole, and then what? They encounter all these new challenges, right? Like Miller's planet, that water world where time is all messed up because it's so close to the black hole.
Yes. Time moves differently on Miller's planet. Thorne actually calculated that for every hour spent there, 7 years pass on Earth.
Whoa, wait a minute. So if I spent a day on Miller's planet, decades would have passed back home.
Yeah, it's a crazy illustration of time dilation. You know, how time is relative and all that.
Okay, my brain hurts again.
Haha, I know, it's tough to wrap your head around. And don't forget those massive waves on Miller's planet. Thorne says they're caused by Gargantua's tidal forces.
Tidal forces, that's like the pull of gravity.
Yeah, but on a massive scale. The black hole is basically stretching and squeezing the planet, creating these enormous waves that would, like, dwarf anything on Earth.
It's a good reminder that black holes aren't just, like, sitting there. They're actively shaping everything around them. And those tidal forces, they come into play again when they try to escape Gargantua's pull, don't they? They use that crazy slingshot maneuver around a smaller black hole.
Oh, yeah, that scene is wild. Thorne says that kind of maneuver could actually work, using the smaller black hole's gravity to boost their speed.
It's like they're, I don't know, playing a cosmic game of chicken with these black holes.
Haha, yeah, something like that. But it shows how much ingenuity and risk-taking might be needed for, future space travel.
Right, right. It's not going to be easy. But the crew in Interstellar, they don't just face challenges from the physics of black holes, right? There's also the human element, all the psychological and ethical dilemmas.
Oh, absolutely. Like what happens on Man's planet, remember? Dr. Mann, he's driven by fear and desperation. He manipulates data to make it seem like the planet is habitable.
Yeah, he's not a very nice guy.
It raises some interesting questions, though. Like, how would being on a long space mission, with all that isolation and responsibility, how would that affect someone's psychology and decision making?
That's a good point. Even with all the advanced technology, the human factor is still crucial.
Absolutely.
But even with all these challenges, Interstellar still ends on a hopeful note, doesn't it?
Yeah.
Like, even against impossible odds, humanity finds a way.
Yeah, it's a story about resilience. And then there's that mind-bending part where Cooper enters Gargantua's event horizon.
The point of no return, right?
Exactly. And once you cross that, our understanding of physics just breaks down.
That's where Thorne really lets loose, doesn't he? He throws in all these speculative ideas about quantum gravity and higher dimensions.
It's like he's trying to imagine what could be beyond the singularity of a black hole.
A place where time and space are totally distorted.
Yeah, and where the very nature of reality is, up for debate.
It's wild, but even then, he's still trying to keep it somewhat grounded in science, with ideas like the bulk of the possibility of, like, higher dimensional beings.
It's amazing how science fiction can really push the boundaries of our imagination.
It makes you want to go out and explore all these mysteries for yourself.
Definitely.
Okay, so before we go any further, what's, like, the biggest takeaway for you from all of this?
Honestly, it's mind-blowing how much we don't know about the universe expert speaker. Like, it's this vast, mysterious place, and Interstellar, with all the science Thorne put into it, expert speaker, it gives us this glimpse into these crazy concepts expert speaker, and it really makes you question everything.
I know, right? Like, everything you thought you knew about space and time kind of goes out the window. And it's not just about understanding the universe out there either. It makes you think about, like, our place in all of this, our own humanity, the ethical stuff, the psychological challenges the crew goes through, the choices they make. It's all like a reflection on us, too.
I totally agree. It reminds us that, yeah, we want to reach for the stars, but we also got to understand ourselves first, our strengths and our weaknesses. It's like a journey inward as much as it is outward.
And through it all, Interstellar still gives you this sense of hope. Like, even when everything seems impossible, human ingenuity, courage, love, all that stuff, you can actually prevail.
Definitely. It's a message that goes beyond just science fiction. It's about the human spirit, that drive to explore, to understand, to hope for something better.
And Thorne doesn't shy away from the big questions either. He really challenges us to think about what all these mind-bending concepts mean. For us, here on Earth, for our future.
Yeah, he makes it clear that the universe isn't just some static background. It's this dynamic, ever-changing thing, and it's full of wonders that we haven't even discovered yet.
It's like he's saying, go explore. There's so much more out there.
He wants us to push the boundaries of what we know, reach for the stars, literally and figuratively.
I love that. But he leaves us with this one question that really got me thinking.
Oh, which one?
He asks, if there are other advanced civilizations out there, are they using these techniques we've been talking about?
Yeah.
Like gravitational slingshots and wormholes to get around?
Huh.
Are they even aware of us, watching us try to figure it all out?
Whoa, yeah, that's a heavy one. Makes you feel pretty small, but also kind of excited,
Right, like, what if we're not alone in this? Who knows what else is out there just waiting to be discovered?
Exactly. And maybe someday, thanks to people like Kip Thorne, we'll be out there exploring alongside them.
That would be amazing. But until then, we can keep exploring with our imaginations, right? Inspired by science and stories like Interstellar.
Couldn't agree more. So keep looking up, keep asking questions, and never stop exploring.
Couldn't have said it better myself. And that wraps up our deep dive into the science of Interstellar. Thanks for joining us on this incredible journey, and as always, keep those fascinating sources coming. We can't wait to see what we uncover together next.